An AI agent can leak private data just by opening a link. This episode gives you a screenshot-ready AI agent link safety checklist for deciding what an agent may fetch automatically, what needs confirmation, and what should be blocked before it opens a page, image, or preview. In January 2026, OpenAI published Keeping Your Data Safe When an AI Agent Clicks a Link. It explains a quiet risk. A URL is more than a destination. It can carry an email address, document title, or other private data. The source addresses one specific attack class, data exfiltration through the URL itself. It does not make page content trustworthy or claim that all browsing is dangerous. This checklist is an episode synthesis, not an official OpenAI template. This video is packed with practical, high-value insights to help you get better at using AI. It's a longer one, so follow Tiny Agent and save it so you don't lose it. First, see how a link becomes a data channel so you understand why an agent can leak something without saying the secret in chat. When a browser or agent requests a resource, the destination receives the requested URL and may record it in analytics or server logs. An attacker can place an email address, a document title, or other private content inside a URL path or query and induce the agent to load it. The request may not look like an obvious navigation. An embedded image, link preview, or background resource can load without attracting the user's attention. Even if the agent never prints sensitive text in the conversation, the receiving server may read that data from the requested URL. Before delegating browsing, ask not only what the agent will read, but which complete address it is about to send to which recipient. Keep the boundary precise. The source demonstrates URL-based exfiltration, not that every page can steal an entire conversation. Chapter Recap. First, a URL can carry data as well as a destination. Second, background resource requests can happen quietly. Third, acceptance checks the complete address and actual recipient. Next, separate domain reputation from the complete address so a familiar brand does not become automatic approval. A natural defense is to let an agent open only well-known websites, but that reduces only part of the risk. Many legitimate sites support redirects. A link may begin on a trusted domain and immediately forward the request to an attacker-controlled destination. If the safety check sees only the first domain, it can approve a chain whose final recipient is completely different. Overly rigid allow lists create another problem. Frequent false alarms can train people to click through warnings without thinking. The source proposes a more concrete question. Do not ask only whether the site looks reputable. Check whether this exact URL was already observed publicly. OpenAI uses an independent web index with no access to user conversations. A known public URL may load automatically. An unverified one is replaced or requires explicit user action. Chapter Recap. First, a trusted first hop does not prove the final destination. Second, the object of review is the exact URL, not the brand name. Third, excessive warnings can weaken human judgment. Then reduce risk before the agent opens a link so vague permission becomes an inspectable action. Ask the agent to show the complete URL, why it needs the resource, and what it expects to retrieve instead of naming only the website. Inspect the path and query for an email address, document title, account identifier, internal keyword, or content copied from the current conversation. If the address carries user-specific data, remove those parameters and use public search terms, a public landing page, or another source independent of the conversation. For a short link or redirect, identify the final destination first. If you cannot, do not treat the familiar first domain as complete evidence. When the product says a link is unverified or may include conversation data, treat that as a human decision point rather than routine friction. For private documents, authenticated accounts, payments, credentials, or irreversible actions, a person inspects the original page instead of allowing a background fetch. Chapter Recap. First, show the complete address and purpose before opening. Second, user-specific data does not belong inside the URL. Third, people take over high-risk context. Now classify external link requests so you know when to automate, confirm, or block. Low risk means a public article or image at a known address with no sensitive context. It may load automatically, while the result is still checked against the expected page. Medium risk means a new address, short link, redirect, or complex parameters. Pause and show the complete URL, destination, and required data before a person approves it. High risk means private data appears in the address or the request touches an authenticated account, internal document, or high consequence action. Block by default and choose an alternative. Do not ask only whether the user trusts the site. Ask whether they are willing to send these exact data in this exact address to the final recipient. If the answer is unclear, have the agent choose a public source, state the summary it needs, or hand the link to a person for manual opening. Record the requested URL, final destination, data used, approver, and result receipt so the decision can be audited and safely reused. Chapter Recap. First, only public links without sensitive data qualify for automatic retrieval. Second, new addresses and redirects require confirmation. Third, private data or high-consequence actions are blocked by default. Finally, complete the AI agent link safety checklist so you have a reusable card for browsing workflows. Box 1 Records Necessity. Why must this link be opened, and can a public search or summary replace it? Box 2 records the complete address, protocol, domain, path, and query instead of a brand name. Box 3 records the data payload, email address, document title, account identifier, internal keyword, or conversation content. Box 4 records the final destination, short link or redirect, actual recipient, and whether the exact address is known, public or product verified. Box 5 records the action level, public low-risk links load automatically, new links pause for confirmation, and private or consequential requests are blocked. Box 6 records the alternative and receipt, switch to a public source, let a person open it, and preserve request, approval, and outcome evidence. Screenshot and save this checklist. Use it before your next AI agent opens an external link. Chapter recap. First, prove that opening the link is necessary. Second, review the address, data, and final destination together. Third, preserve the action level, fallback, and receipt. To sum up, an AI agent can leak private data just by opening a link. Do not treat domain reputation as complete proof. Inspect the data inside the URL and the final destination after redirects, then automate, confirm, or block. AI can discover links and prepare retrieval. People protect private context, approve exceptions, and take over when the destination is unclear or the consequences are high. What should an AI agent always show you before opening an external link? Tell me in the comments. Follow Tiny Agent. Tiny Agent helps you get better at using AI.